morning, students. My name is Mara Gadno. I am a physics teacher. Today, I teach you Physics Grade 8, Unit 4. The topic of Unit 4 is heat and energy. Before I started this topic, I revised last year you learned it in Grade 7 Physics. In Grade 7 Physics, you learned about temperature and heat. Students, what is temperature? Do you remember? Temperature is one of the fundamental physical quantities like mass, time, and length. So, and the other temperature is the measure of hotness or coldness of a body. The instrument which is used to measure a temperature is called thermometer. There are different types of thermometers. Mercury thermometer. Under mercury thermometer, there are clinical and laboratory thermometers. These clinical and laboratory thermometers made up of mercury. And the other, alcohol thermometer. It is used to measure very low temperatures. And also, the SI unit of temperature is called Kelvin. Now, I started Unit 4, heat and energy. Students, what is heat energy? Heat energy is the total kinetic energy of all particles in a given substance. These particles are atoms or molecules. And the other, the SI units or standard international units is joule. This means the SI unit of heat energy is joule. Calorie is another unit of heat energy. Calorie is another unit of heat energy. 1 calorie is equal to 4.2 joule. Now we see source of heats. The source of heats are renewable and non-renewable heats, heat energies. Renewable using continuously. We can use this continuously. But non-renewable heats of source used only one time. This means non-renewable source of heat energy is used only one time. Sun is a renewable heat energy, and also wind energy, hydroelectric energy, geothermal energy. These are renewable. We can use continuously. And the other, kerosene, petroleum are non-renewable. Coal, firewood also non-renewable resource of heats. Now, heat transfer. Heat transfer. Heat transfer is the movement or flow of heat energy. The movement flow of heat energy from hotter body to colder one. From hotter body to colder one. This means heat transfers from a high temperature to low temperature. Heat transfers from high temperature to low temperature. Heat transfer occurs when there is temperature difference between two bodies or two parts of the same bodies. There are 3 types of heat transfer methods. The first one, conduction, convection, radiation. Conduction, convection, radiation. By image, convection, conduction, radiation. Let's see one by one this. Conduction. conduction is one way of heat transfer. Conduction is one way of heat transfer. It takes place from hot body to cold body. It takes from hot body to cold body. This means high temperature to low temperature. It takes place from hot body to cold body by means of successive collision between two neighboring particles. Heat energy can transfer from one body to the other. They are in thermal contact. And also, conduction is mainly seen in solid objects. Materials which do allow that to pass through them are called conductor. Materials which do allow heat to pass through them are called heat conductor. And the other materials which do not allow heat to pass through them are called insulator. Now we see the insulators or poor conductors and the most effective electrical heat conductor and the most effective electrical heat insulator or poor conductors. Silver, gold, copper, aluminum, mercury, steel, iron. These all are conductors. It transmits heat energy one body to another. And also the most effective electrical heat insulator or poor conductors are rubber, glass, oil, air, diamond, dry wood, plastic. These all are poor conductors, does not transfer heat from one place to another. The second one is convection. Convection is a type of heat transfer. Convection is a type of heat transfer, can only happen in liquid and gases. These liquid and gases called fluids. There is temperature difference between liquid and gas. There is a temperature difference between liquid and gas. This means the temperature of liquid is different from the temperature of gas. The transfer of heat from one place to another by actual movement of a particle of the medium. This is another meaning of convection. And also, convection takes place primarily on fluids, gas and liquid. As a convection, heat is carried by the moving medium. As a convection, heat is carried by the moving medium. Example, boiling water in a dish use a convection. The other is air conditioner, radiator, hot air balloon, refrigerator. This is all about the examples of convection. The third is radiation. Radiation is the emission or transmission of energy in the form of wave. The radiation is the transfer of heat from one place to another without material medium. The heat of the sun reaches the earth by the process of radiation. Is an example of radiation. And also, heat can be transferred by radiation in vacuum. This means heat transfers in a vacuum. Heat radiation is carried by an electromagnetic wave called infrared wave. This wave is not visible to human eye. We cannot see this wave. Example, a burning candle emits radiation in the form of heat and light. A burning candle emits radiation radiation in the form of heat and light. The sun emits radiation in the form of light, heat and particles. Heat, light and particles. The other is a specific heat capacity. A specific heat capacity. It is the amount of heat energy needed to raise the temperature of 1 kilogram of mass, a substance, by 1 degree Celsius. It's called specific heat capacity. A specific heat capacity expressed mathematically, C is equals to Q over M change of T, where Q is heat gained or lost. This means heat energy, and also M is mass of the body. T is change of temperature. This means T change of T means T C is equals to Q over M times change of T. Q is equals to heat energy or heat loss or gain. M mass of a body. Change of T is equal to change of temperature. This means T2 minus T1 or TF minus TI. TF minus TI. Now C is equal to Q over M change in T, formula 1. And we can get another formula from this. C is equal to Q over M change in T, crisscross. Q is equal to C times M change of T. We can say this. Q is equal to MC change of T. Q is equal to M C change of T, formula 2. And the other, we can get M from this formula. Q is equals to MC change of T, C times change of T over C times change of T. Change of T, C cancel by C, change of T by change of T. M is equals to Q over C times change of T. Formula 3. Now we can get the formula of temperature. The formula of temperature is equal to M is equals to Q over C change of T, crisscross, M times MC change of T is equals to Q over MC over MC, then MC by MC, change of T is equals to change of C is equals to Q over MC, formula 4. So formula 1, C is equal to Q over M change in T. Formula 2, heat energy is equal to MC change of T. And also mass of a body is equal to heat energy over specific heat capacity times change of temperature. And also change of temperature is equal to Q over M times C. Different substances have different value of specific heat capacities. Different substances having different value of specific heat capacities. C is the specific capacity of liquid in joule per kilogram degree Celsius. Now, the substance water is 4,200 joule per kilogram degree Celsius is specific heat capacity, and salty water 3,000, aluminum 900, iron 480, copper 335, lead 130, glass 670, rubber 1700. Example. How much heat is required to raise the temperature of 500 grams of iron from 50 degrees Celsius to 250 degrees Celsius? Use the specific heat capacity 418 joule per kilogram degree Celsius. Mass is equal to 500 gram. This means 0.5 kilogram. 1 kilogram is equal to 1 kilogram is equal to 1000 gram. So 500 gram is equals to 500 gram is equal to crisscross method 0.5 or 1 over 2 kilogram. So Ti initial temperature. Ti is initial temperature 50 degrees centigrade. Tf final temperature. The final temperature is 250 degrees Celsius. And also C 418 joule per kilogram degree Celsius. This is iron, the specific capacity of iron. Q is equal to heat energy, required heat energy, M times C change of temperature. M times C change of temperature. Then Q is equal to M 0.5 or 1 over 2, 0.5 kilogram, 0.5 kilogram times C 418 joule per kilogram degree Celsius. Times the temperature 250 degrees Celsius minus 50 degrees Celsius. Then zero point five kilogram times 480 joule over kilogram degree Celsius times 250 minus 15, 200 degree Celsius. Now kilogram cancel by kilogram. 0.5 we can write 1 over 2 times 480 joule times 200 degree Celsius. 200 degree Celsius. This also 480 divided by 2 joule times 200 degree Celsius. 200 degree Celsius. This is 240 times Joule times 200 degree Celsius. The answer is 240 times 200, 48,000 Joule. 48,000 Joule. These 48,000 Joule we can convert into kilojoule. 48 kilojoule. 48 kilojoule. So the answer is 48 kilojoule. Example 2. How much heat is lost by a copper bar weight of 2000 gram when it cools from 100 degree centigrade to 40 degree centigrade? Use 385 joule per kilogram degree Celsius. Now given mass of the body is 2000 gram. This is 2 kilogram. 2000 gram convert into kilogram to kilogram. Ti initial temperature 100 degree Celsius, and also Tf final temperature is 40 degree centigrade. Now the required is Q. So Q is equal to MC change of T 2 kilogram times 385 joule per kilogram degree Celsius times from this the final 40 degree Celsius. 40 degree Celsius minus 100 degree Celsius. This means 2 kilogram times 385 joule per kilogram degree Celsius times minus 60 degree Celsius. This is 2 kilogram by cancel by kilogram, degree Celsius by degree Celsius. This is minus joule. This negative sign indicates the heat is lost. The heat is lost. The answer is 46,200 joule. እሺ ተማሪዎች ለዛሬ የነበረን ትምህርት ይሄን ይመስላል። በሚቀጥለው ክፍለ ጊዜ እስከምንገናኝ በቤታችሁ ናችሁ ራሳችሁን ከኮሮና በሽታ እየጠበቃችሁ በቤታችሁ ናችሁ እንድታጠኑ እላለሁ። አመሰግናለሁ።